taking a quick look at errors. Didn't really have one, I don't think, on this board, except that these two diagrams here were the result of having formerly had a sine function here, cosine function works much better for explanations, just easier to see the phase relationships with the cosine. So these would have been the phase relationships had this been a sine function. The phase relationships would still be the same, but the phasor picture would have to project onto a vertical rather than horizontal axis, and that wouldn't have been very as easy to see. It's not what you're traditionally used to. A few errors that were here. I had a 1 over omega c in class. It's Imax over omega c, and it should be really obvious why that should be Imax over omega c, because the Imax shows up in both the derivative and the antiderivative. Not sure I wrote down all this stuff, but the assumption is I of t is Imax cosine of omega t, from which it follows that the voltage across the inductor is negative omega L Imax sine omega t, and across the capacitor is 1 over omega Imax sine omega t, which was already done previously just by doing the derivative and the integral. And I also noted that VR, the voltage across the resistor, is R times the current being an instantaneous response over any small length, smaller than 1,000 miles, to the voltage. Okay. Now let's see. There was in class a V sub R here, which makes this look like the voltage across the resistor. The R, I think, was supposed to stand for resultant, but who knows what I might have been thinking when I did that. I had an angle minus phi here, and I just had one arrow on the angle in this direction. Well, if the angle's in this direction, phi is already negative. And phi is understood to be negative. I put two arrows in this to indicate that this angle here is the magnitude of phi, and that phi in this orientation is negative, and that helps correct my result for phi, which was correct. I thought that this was upside down for some reason. I wasn't thinking real clearly, but this is the correct result. I had a positive here and a negative here, but having corrected for this, we got that right. I had not rewritten the results for the impedance, basically, but as you can see from the discussion, we added the resistance across the resistance across the voltage across the resistor to the sum of the voltages across the inductor and capacitor, so that now our voltage of the source is going to be this, and that leads us to the fact that the maximum voltage is going to be Vmax times the square root of the sum of the squares of this and this, simply because the sine is perpendicular to the cosine. So this is basically the hypotenuse of a right triangle, with this as one leg and this as the other. So you get Vmax equals this, and then I wrote that out a little more clearly. Hopefully it's readable. And I also used the Z term, Z, for the inductance. And it's 1 over omega C minus omega L quantity squared plus R squared. If you can't read that, maybe a little clearer up here, but not all that clear either place. I also replaced the parentheses around this factor with absolute value signs, so that Vmax and Imax would be magnitudes. All these quantities would be positive. And also noted that 1 over omega C is X sub C capacitive reactance, and negative omega L is X sub L inductive reactance. And the total reactance, for reasons that are very clear by the opposite directions of these voltages on the phasor diagram, the equivalent inductance is just this magnitude of this. And this would allow us to change the sign, have a negative on this one, a positive on this one. which is probably consistent with the way it's usually written. On this board, the error was, and I pointed the fact that there's an error out, is simply that I didn't include the factor 4 pi k in the divergence of the electric field. You can see the video to see how that works out. But the electric field being the integral of 4 pi k q over r, the divergence of the electric field would be 4 pi k times the rho, the density of the charge. And then this here would be 4 pi k times the enclosed charge, which is then consistent with the idea that the electric field times the area of the surface, the total, which is the total flux. Total flux is 4 pi k q, which is something I just kind of handed to you in class. But here's the connection of that with the divergence theorem, and the connection of the whole Gauss's law idea with that of the divergence theorem.